Hello there, and welcome to dealing with lefties, righties, tweeners, and splits, our mortal enemies. This video is going to be strictly on lefties because I have been having difficulty getting my righty video up and running. So this is just going to be a start to normal distributions. For those of you Cypress College students who I'm referring to now, these deal dominantly with the Chapter 7 and Chapter 8 problems that you've been working with this past semester. So there's a couple of rules that we have to establish when we're talking about lefties. And one of those rules is that if you're dealing with a z distribution, well, any normal distribution as a matter of fact, the center is the mean, and you usually come up with the following particular notation, where we say x is any variable. Now when we're referring to variable, it could be the IQ scores, it could be the reading speeds, it could be oil change times, whatever you're referring to. And the number is given to you. So they'll say, less than, 35 minutes. Well, then you would go off and you would start working in interval notation. This is something that you covered in Math 40, and the negative 999 is referring to negative infinity. This is why this is often referred to as a lefty, because the negative infinity is on which side? The left-hand side. Okay? And if this feels really basic, we're going to go into a short example. So in Chapter 7, they would tell you, okay, so your average is 20. Standard deviation, let's make it a nice number, 30. And the z-score equation, which we can't forget because sometimes your teachers will ask you for a z-score. There you go. If you don't know this one, it's way back in Chapter 3. Your x, nice numbers this time around. Let's make it a 50, and let's see, 50 minus 20 divided by 30. Let's see, that comes out to roughly a positive 1, I believe. And if we do our second example, we can make x negative 10 in this case. Now, mind you, the negative 10 is given to you. The 50 is given to you. The 20 is given to you. The 30 is given to you. Your only job is to fit everything in the right place. So this 50 belongs in its x spot, and this negative 10 also belongs in its x spot. The 20 belongs in its spot, and the 30 also belongs in its spot. That's where these individual numbers are coming from. So what we're really looking for in proper notation is the likelihood that z is less than 1. And we're also looking for the likelihood of z being less than negative 1. By doing this, if we were to draw this out properly, and I emphasize properly, the center of any z distribution is 0, and we're looking for that boundary marker 1, and going off in which direction? The left. If you don't know which way we're going to follow the arrows. So you can look this up on a z table depending on who your teacher is, but most of you are going to refer to the normal CDF function. And the normal CDF function works along interval notation. In this case, because it's a lefty, negative infinity going up to positive 1. And as opposed to the negative 1, draw it out again. Keep your center at 0. And we're not doing positive 1 this time. We're going to do it for negative 1, and we want it to the left. So again, you can refer to your z tables from before, or you can do a normal CDF, and this is a lefty, of negative infinity. Wait a minute. I'm missing something here. What am I missing? That's right, a negative. Going off to negative 1. And for those of you who don't remember what the normal CDF function is, it's available on all TI 83 and 84s. Let's see, TI 83 and 84. And it's going to be under second, which is on the top left-hand corner, and vars. So when you hit second, it's usually going to be some weird orange color, or it's going to be some weird blue color, depending on who you are. But more importantly, sometimes they'll ask you for a couple of extra inputs. But if you just stick with this, you should be getting the following answers. So let's go ahead and just review just for a little bit. If you're dealing with this particular distribution, where you got a z-score of 1 and you're looking to the left, the area for it from the output of normal CDF is 0.8413. If you're dealing with -1, then you should have an area of 0.1586, and that's after punching in these numbers into your calculator. Sometimes, for those of you who have 84s, it'll tell you, okay, what's your mu and what's your sigma? Well, the mu is 0 and the sigma is 1. And that's just because that is the standard for a z distribution. So you get a lower bound, upper bound, the mean of the distribution, and the standard deviation of that distribution. All right, so last time we found a z-score of 1 from the previous example that we did. If you need to, go ahead and rewind. And we got a -1. We had 2 individual questions where all that information was given to us. And we wanted to find the area to the left of 1 because this arrow was pointing to the left. And we wanted to find the area to the left of -1, and that's the area over here. By plugging it into our calculator using this notation, you get 0.8413 and 0.1586. Thank you very much for watching this video. I'll be sure to try and get as many righties and tweeners and splits. You do need to know how to solve all 4, but if you can start with this, you should be able to figure out the rest.